This video is about simplifying radicals, but I want us to be reminded of two laws of radicals. Okay, the square root of AB is the same as taking the square root of the individual terms under the radical. Okay, so the square root of AB means the square root of A times the square root of B. Also, the square root of x is the same as x raised to the 1/2 exponent. Okay, all right. Now we want to simplify the square root of 50. Now I want to break this 50, which is a radicand, that thing under the radical. I want to break it such that I get, I want to break it in terms of two of its factors. But I want to ensure that one of its factors is a squared number. And when I say squared number, I'm talking about numbers like 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, that kind of thing there. Okay? Alright. Now, so I can break this as, I can write my 50, my root 50, as the square root of 2 times 25. Because 2 times 25 is 50. Now I can write this part like this. So I can write it as root 2 times root 25. You see that 25 is a squared number. Now I know that the square root of 25 is 5. So I can rewrite this thing now as root 2 times, this is the root 2, and the square root of 25 is 5. So I can rewrite this as 5 root 2. And this is my answer here for this. That is that there. Okay, let's look at example 2. Example 2 is the same kind of principle, but we're going to step it up a little bit. Okay, now when you have situations like this, you want to break the radical, just as we said before, so that the individual terms under the radical has its own radical. Okay, so I can break this as the square root of 75 times the square root of x to the 4 times the square root of y to the 5. Okay, now again I want to break this 75 in terms of a squared number. Alright, so I can write this as the square root of 3 times 25, because 3 times 25, that is 75. Okay, times, once your exponent, if your exponent is an even number, it's okay, you can have it remain as is. So I can write this thing as x to the 4 there, because the 4 is an even number. Now my exponent here is an odd number, so I'm going to break this in terms of, I'm going to step it down by 1. So I'll have the square root of y to the 4. That's stepping this down by 1, but I have to account for that 1. Okay, so again, if you go back to the laws of exponent, y to the 4 times y to the 1 is y to the 5. Okay, now this part here would be the square root of 3 times the square root of 25, because each thing under the radical is going to have its own radical, times the square root of x to the 4 times the square root of y to the 4 times the square root of y. So I didn't do anything with these, I just rewrite them. Alright, now I know the value of the square root of 25, that is 5. So I can rewrite this part here as 5 root 3. So this 5 is the square root of the 25, and my root 3 is here. Now remember this, that the square root of x is the same thing as x to the 1/2. So when I take the square root of this, it's going to half this exponent, and half of 4 is 2. So this solution here would be times x squared. Okay, the square root of y to the 4 is going to half this 4, which is 2, so that is just y squared as well. I don't know what the square root of y is, so I let it remain the square root of y. Okay, all the values that do not have a radical, I'm going to pull them to the front and times them. So this doesn't have a radical, this is not under radical, this is not under radical, this is not under radical. So I'm going to group them to themselves, put them at the front. So that's going to be 5x squared y squared. The two things that are under radical, I'm going to times them and keep them under a single radical. So it would be the square root of 3 times y, that is 3y. And this would be my final answer here. Okay, Now let's look at our final example. Now our final example says we should take the square root of 15 upon 6. But I want us to remember that the square root of a, and I should put a b here, the square root upon a upon b is the same thing as the square root of a divided by the square root of b. So with this, I'm going to break this in terms of this law. So each thing under the radical should have its own square root. So it would be the square root of 15 over the square root of 6. Again, I can break these numbers under the radical in terms of factors. So this I can write as 3 times 5, because 3 times 5, that is 15. Over, I can write this part here as 3 times 2. 3 times 2, that is 6. So I could rewrite this thing as the square root of 3 times the square root of 5. This is for the numerator here, divided by the square root of 3 times the square root of 2. This is for the denominator here. And then clearly we can see that the square root of 3 can cancel the square root of 3 there. So what I would be left with is the square root of 5 over the square root of 2. Now, you don't want a radical to be in your denominator, because we don't know what the square root of 2 is. It continues on and on and on and on. Okay? So you cannot divide by something that doesn't end. What will your solution be? You don't know. So you want to remove the radical from the denominator there. So to remove the radical from the denominator, I'm going to multiply both numerator and denominator by whatever my denominator is. Only if there's a radical in the denominator. Okay? So this would be square root of 2 divided by square root of 2. And I divide numerator and denominator by the square root of 2 because that is what is in the denominator here. Now I could go back to my law. If you remember my law here, root AB is the same as root A times root B. Okay? So if I multiply A times B, I can keep it under one radical. Okay? So this I could take this part here as root 5 times root 2 would be the same as root 10 over root 2 times root 2 is the same as root 4. But we know what the square root of 4 is. The square root of 4 is 2. So our final answer is just root 10 over 2. And this is our final answer there. Okay? Hope you have learned something, and I hope simplifying radical becomes a little bit easier. Have a great day.